Okay, so this is your model. We discussed it before that the ground level is variable, so you have here the soil and it goes down on this area, and you considered it to be fixed here, which is it's let's say conservative. It is a conservative approach, and then we'll place the rafter. For wind, we need to define panels. You have here some instructions about wind. So you can also check this manual for 3D wind, where you will find more information regarding the correct definition. We'll go through it together. So, but if you want proper information, you can always check these options, and there should be also a manual here for the wind generator on how it works. Basically, we'll run it together
Yeah.
now. First of all, we will need to make sure we enclose the entire building with panels. We either use the 2D shear wall elements, or we need to cover everything with this type of panels. So the 3D wind generator only works on closed structures, so we will need everything to be closed. Second of it, we will need to establish for each panel on which elements it will transfer the load. So basically,
Yeah.
we will start like this. We go to project and then select functionality, climatic loads, it's selected. Then we'll go to actions, wind load. We can establish here some basic settings, but first of all, I will need to check the coordinates of your building. So I'll go to this lower point and I'll see it's -3, and from here I think we have around 0, because the wind action should start from a certain elevation point. So let's see here, 9 point. So I guess here can be 3.2. So then this is ground zero. So we'll assume the wind will act starting the ground zero. However, in this your situation, as I see these walls, I understand that the wind will start at this 3.2. So this will be the lowest point from which the wind starts. So we go to functionality, climatic loads, actions. It will be according to Eurocode. And here you established a speed of 3.55 meters per second. And then we should establish the terrain category. You know what is this about? This terrain category?
Yes, I know.
Okay,
Related to the
it is
uh,
related to the neighboring areas. So basically, if we would like to check if it's okay, because I
yes.
think it's not okay the way you chose with 0, but I need to check it with you. So I'll just open some Eurocode on this matter.
Helpful category.
1.4, and go in that specific table. So it will go to table 4.1. Okay, so this is how we establish the terrain category. So is your terrain sea or
Yeah.
coastal? This is
Yeah.
0?
Yeah.
Okay,
Yeah.
okay,
It's
so we'll
fine.
keep it 0. Okay, that's enough for this setting. We'll hit OK. And you have snow or not? You don't have snow.
No.
Okay, so
Yeah.
it doesn't matter what's on the snow load. Okay, so this is about setting up first the generation, the model generator. Second, we will have to have a look on these panels. So in order to be able to generate the 3D wind, all panels that will support the wind load we need to have this 3 wind option. So I will select all your panels, and I see only a few have this option. So let me see, flat. I will select all the panels here, and I will isolate them, activity by selection. So this is just these are just the panels, and then we will have some exterior shear walls that will also take the loads, the wind loads. We will first handle these ones, so I will select them, go to panel, and here we have 3D wind activated. Load transfer should be in all ways, so we will have bidirectional transfer, or we can establish only to transfer to the columns. How do you wish to transfer to the columns only, or also to the beams?
For this,
yes,
it depends on the
cladding system.
Yes, the structure applied to the column or beam. For me, at no column, so applied to like a point load, not applies to the beam.
Okay, but you don't have the cladding models, so we need to somehow get the wind. We can do it in points, as you wish actually, if you want it, because normally you can do it in points, but normally there are more points on a column, so it's not just the start and the end of a column, but also intermediate points. So where you have the horizontal beams of the substructure for the cladding system, you will establish there what to do. Okay, now it's loading something. It's not bad the way you modeled with horizontal and with points. So if you want to get all the wind loads inside points that are concentrated at the end of the column, it's okay the way you did. So actually I'm going to close this and open it again. I don't want it to waste time, so I'll just open it again because I didn't do any changes to your model, so it's no problem. And I will keep them in nodes as you said. What I'll need is also to make 3D the shear walls, the exterior shear walls.
Păi voiam să văd și eu ce opțiuni, ce chestii. Nici opțiuni. Dar eram aici.
Okay, so we'll go back to what we said. So if you want, yes.
Excuse me. Yeah.
On this side of the shear wall, you will get an uniform distribution within the wall that will act on the nodes. So basically in the end you will get similar thing, but as settings point of view, they are quite different. So it's okay the way you set the panel to nodes, so it will only get concentrated force in nodes, and we can see them once we manage to generate the 3D wall. And then we can also see how the walls behave. What we'll need to do is starting the 0 coordinate, or so I say the wind will act from this 3.2. So we need to have an envelope of the building in order to generate wind. Otherwise, in open structure, we won't be able to generate the wind. So if this is ground 0, we'll do like this. We will select this building. And select only the enclosing structure, so only the edges. And we'll have to make sure that everything that is selected has 3D wind activated and that the arrows are pointing outwards. So for panels we will have a local coordinate system with the Z, but also for the walls we'll have the same situation. So we will be unable to generate the wind unless we have everything closed. So now that I isolated this part, I will need to add some other panels so I get an enclosed box. For this I will deactivate here this one, and I will copy the elements. Yes. Okay. And I'll have to draw another panel here.
So we assume the building
Is fully closed.
Closed, but another elevation in like
Yes, but
this one have a soil, so the wind cannot.
no, on this area we will not draw a panel. We will activate the 3D wind on this area, so it will have the arrow pointing outwards. However, I have to enclose the building in order to use the 3D generator, otherwise it won't generate the wind. So this is a method from Eurocode, but is dependent on closed structure. So this is why I need to do a fully enclosed with panels or walls model of your structure.
Yeah.
For all the area where the wind acts. So
yeah,
that's one
although some area the wind cannot flow.
Why cannot flow? Maybe it's it's open, or what do you want to say?
Because this one in the ground.
Yes, I will not. I will say that
in the soil. So
I understand and I agree with you. So this is why
we assume.
Yes, but this is how we do here. So the moment you specify that the ground level is at here, so if this is the reference level of terrain, starting this coordinate upwards, the wind will act. In your situation, the terrain is not at the same level, so we can only do a conservative approach and pick up the lowest point where we have no ground, and we assume that the wind will act starting at that point. it will be conservative, so it will be on the safe side to do this approach.
Yeah.
Okay, now I'll have to close it here as well. And also underneath it is required.
Pin load transfers to the column.
What?
The load, the panel load.
Yes.
The panel you applies to the column.
No, I applied to nodes, so it will only load the nodes with concentrated forces.
The point load.
Yes, it will convert this into point loads, so I can show you the result of the transfer once we do all the panels and we are able to generate the 3D wind. So only then can I show you how we do this. So for everything we need to have this 3D wind selected, but it's okay, you're right. So let's see if I have others as well. So we will just transfer to nodes so they don't load the columns themselves directly, so they will load through the nodes. Okay, then we'll make sure that all these elements also are taking the wind load. So we'll go to 2D members and pick this 3D wind structure.
Yes.
Okay, we'll also do some saving to have no problem. I'll wait a bit. Okay, now do you have wind also on this, right? They are acting also on this top side. I will have to create some panels here as well. So let me see how the structure looks or continues in this area. Okay, so we'll also need to do an enclosing here. Okay. And then we have these sides. But I recommend for all to transfer both directions. So it's okay to transfer to the node, but not necessarily X direction, to let the program establish in which direction the percentage is. So after I finish the panels, I will input that all will have both direction as a transfer, because it only transfers to the nodes, and the nodes will decide which to go further. I'll have to activate the structure in order to finish this upper part. Okay, I didn't need that panel. I will delete this one. I didn't see that on this side we already have some elements, so I have to do some fixings here on the last level. So So we'll select only the last level. I have to remove these panels and only place them for the closings. Okay, I think I deleted the slab also. But you don't have here, you have here a 2D, the slab. Is it a slab here on top or not?
Have a slab on top.
Did I delete it or why can't I see it? Because I have the entire building available now. Okay, I think I deleted. Yes. So I'll just close with the panels this part and then see. Okay, and on this area we also need to enclose it somehow. Okay, it seems right. However, this wall is longer than the building. This is how you want it. This sheer wall is longer than the rest of the building. Are you sure? It's okay. And this also. Oh, because we might get some errors when generating wind. We will check it. If we get errors, we'll need to divide this wall into two options. Actually, I'm going to do this now to avoid any potential errors. I'll go to modify, divide surface, select this panel, hit escape, and divide it here and escape. And now select only this portion of it. And we will hit 3D wind. Okay. And also we'll have another look at this top area. It's very important that it will have everything is closed, otherwise we'll get errors when generating the wind. And in your model, the wind is really important because you don't have seismic action, so only the wind will bring significant horizontal loads. So it's very important that we generate it correctly. The program is quite sensitive, so unless we make everything closed, we won't be able to generate 3D load. Also, there is no need to overlap elements. So if I have a 2D element like a wall or a slab, I will just add
Yeah.
the property of 3D wind, not and not draw panel over it. Make sure here, so I remove only the panels. This panel is okay from the lower side. Let me check here if there are any panels left. So this would be okay. Load panels to points. Okay, actually all the panels in this area should be 3D wind, and we need 3D wind property for this slab. So pay attention not to assign the 3D wind properties on elements that will not be directly loaded with the wind action. So this is quite important to take in consideration.
Yes.
Okay. Also, I have to check the local coordinate system, so all the local axes should be pointed outside of the building. So for the panels we already see them, the local axis, but for the 2D elements we need to activate, and the way we activate is going here to structure and saying local axis onto the elements. And we need to make sure that the axis is pointing outside, like in this one. So the z-axis it's outside. Also for the walls it's okay. So I'm checking that all arrows are pointing outwards, both for walls but also for the panel. So in this situation the arrow is pointing inward, so in order to get a correct wind distribution we'll need to swap the orientation, and the way I do it is just here on the properties I say yes to swap orientation. Okay, so I select the elements and then go again to swap, actually on 2D, to swap the orientation to be outwards. And for this panel it's the same thing. I select the panel and I say swap orientation, so I make sure that everything is outward. This is a sign convention that is written in the manual, but it's important to get the correct wind distribution from the 3D wind generator.
Yeah.
Here I think okay, it's okay on this side. I'll do another save to make sure, and I will check that everything that is lower than 0 doesn't have a 3D wind option on it, so it will not affect the wind generator. So I'm going to see here at you modeled also something. We'll discuss about this. It's not that okay to mix these types of supports. Anyways, let's see. So in this area, starting lower, I don't see anything that has a 3D option, or I should check it. Okay, no 3D wind, which is good. Now I have to check that all perimeter or edge walls have
Yeah.
the 3D
Three.
wind.
3D. Yeah.
So I have to isolate them to make sure that only these have, because if you pick one that is inner, it will generate problems, as it will not interpret correctly the shape of the building. So only edges are relevant in this situation. Okay, so this should also be 3D wind, and the arrow should be pointing outwards. So I swap the orientation. Here it's okay. So if I see this blue parameter, which is the wind data, it means that the wind will be generated on that surface. So if I go here, member data, I'll just click this one, 3D wind generator, and
To that some direction of the
yes,
panel.
yes, and change the direction to
inside.
point
Yeah.
outwards. I can select where I need
Before
to. Yes.
Before this level, I use the load, mean the pressure of the soil.
Yes.
This fall.
So
So
if I change,
don't forget to delete the pressure load.
Yes, you will have to do some changes, because if you already define the pressure loads, but this is the other way, they will change signs, so they won't be correctly anymore. All loads are according to the sign of the 2D element. So indeed, that's a good observation. Okay, here we have them. Okay. Okay, so I will save the model, and then I will change the properties so all panels will transfer the loads both on X and Y direction, and then I will generate the wind to see if it works. The model is not correct from the supports point of view. We will have to discuss about the supports. Let's see, load transfer. I will select all the panels. Also, I will have to make sure that all panels will transfer to loads, so I didn't skip some. So to panel nodes, all okay, but there's also, I need to test if you have any within the building. So I will select activity by selection to make sure that you don't have any panels inside the building. And I see you have, okay, these are not inside the building, which is okay. They're on the top. So all should be 3D wind. Okay, and all should transfer bidirectionally. Okay. Now we'll save the model and generate the 3D wind to see if the generator acts correctly. Yes.
In general, we use the
I will delete the old cases. I cannot rely on them, so I will generate it now. And now I will generate the load. So I'll go to load, select any load, it doesn't matter, and click here 3D wind generator, add load case. I will add all of them and then run the generator and see if I have any errors. If the program encounters okay, we'll assume the assessment that there are no open faces, so it will help us close some areas we did not cover by panels, and we will check it the way it distributes the load, so or transfers the loads. This is how we check if everything is correct.
Yeah.
And also by
very important.
Yes, and also by the way the building will act. So normally if wind acts on a certain side, we should see from the deformed how it looks. Basically, we have to wait a bit now.